Hey, hello everyone, and good morning. We start now, and so today we are going to continue to study the consumer surplus. And as mentioned in the end of last class, we still have one more point, which some students ask me to clarify. I will do that, and at the very beginning of this class. Okay, I just put some notes into the sharing section, but all the notes disappear. Let me redo it. So first of all, at the end of last class, some students don't quite understand this point because, give me a couple of minutes. For this part, we needed to calculate the consumer surplus. And basically, give me a couple of minutes. We needed to calculate this part. You know, the idea is the price of goods X drop from high level P1 to low level P2. At the same time, the price of goods Y doesn't change. And clearly, that's a good thing for the consumer. How good it is, we can measure the benefit the consumer receives from such price change by calculating the consumer surplus. Basically, this part, the size of this region. And at the end of last class, I mentioned one simple way to calculate is, suppose this is A, this is A for the square, B for this part, and C again for only the square. So therefore, the consumer surplus in the John Hickson sense is the so-called CV would be equal to, let me redraw it, equal to A plus B and minus C. Why minus? Because we want to calculate how the size for this part, the square plus the size of the triangle. But the triangle is the difference between B and C. B covers the whole thing, the whole area, and C only oh, thank you. I did forget to record.
Recording in progress.
Thank you so much. And okay, so let's continue our discussing. And so we need to calculate this square plus this triangle. But here, when we consider B cover both triangle and the bottom part, bottom triangle. So therefore, we need to do some subtraction, get rid of the C part. And what's A? A equals clearly the difference between price P1 and minus P2 times X1. And B is this part. That, you know, if you calculate the integral calculus for this curve running from X1 and X2, this will be. Let's just leave it. We still put it here. But C is X2 minus X1 multiplied by P2. Let me put here P2 times X2 and, sorry, minus X1. Okay, and here we have something quite nice in terms of mathematics, because if you consider carefully this part, minus P2X1 here plus P2X1, so therefore we get P1 X1 minus P2 X2 plus B. Okay. So because this term and this term cancel with each other, only P1X1 and P2X2 are left. So I hope this small trick can help some for you to better understand one step when we, sorry, let me put it back. So here, this is what we did here. We, for this part, from this step to this step, this is what we get here. And this is the simple way, sorry, it's a little bit messy now. So this is a quite, childish way to calculate the size of the consumer surplus. But this way may help for you to better understand if you are not very familiar with so-called integration by parts. By parts basically means you just exchange the position of the term before D and the term after D. This is a very simple way to do the integral calculus. But if just in case you are not familiar or you simply forget, don't worry about it. This is a simple way to find. And then still, what's this? This one is what we, okay, let me see. Stop. Okay, this is what we mean by B. B is the definite integral calculus. Consider this as a function of x, and when x is increasing from x1 to x2. If you look carefully, this is it. This is it. And then for this step, then again, we mathematically, sorry. So we are using, sorry. The so-called technical for substitution. And economically, when we change the price, when the price is going down for any level between P1 and P2, and P1 and P2 here is, for example, at this point, at any point, the so-called marginal rate substitution, that is dx, dy over dx, must be the same in value with the relative price px over py. So based on that, we can get this idea. P dx always equal to minus py dy. For any point, for any intermediate level for price. So this is what we have done in last class. So today, we continue our discussion about the consumer surplus. Let me, okay. And, we have already got a very beautiful result. That is based on the Hickson demand curve. If we calculate the change in consumer surplus, this is precisely, this is exactly what we can save, how much money we can save. We don't change our life quality, but because something is cheaper, so we only need to spend less money than before. So how much money less? How many less dollars? So that number is exactly equal to the consumer surplus, the change in consumer surplus. This is a very, very nice result because coming back to reality, if we want to know, for example, with the macro government, somebody may ask us to do some project for them to calculate how much benefit if the government help to decrease the price. For example, they introduce some regulation policy and make sure as the price of some goods, which is important for the people of Macau, to control the price, to make sure the price is not that high, basically to change the price from high level to low level. We know it's good, but for anything good, you have to pay the cost, no free lunch. And so suppose the government needed to spend a lot of money for this one. That's the cost part. What's the benefit part? Benefit is the Macau people, a lot of families, particularly the low-income families, they love it, they benefit. But how much benefit they get? And that is how much money they can receive. And if we collect enough data from the market about the price and about the quantity, we can construct, we can estimate this curve. And based on this curve, we can report a number, this number. We just tell the Macau government, this is how much benefit. If you do that, the Macau people can receive from your policy. And then you just need to compare this number with the cost. And if this number is bigger than the cost, then you guys, you Macau government should do that, because by doing so, our overall benefit for Macau people is larger than the overall cost. So this is one way to calculate, to estimate the overall benefit. And now we built up the scientific, we established the scientific foundation for this estimation. That is, change in consumer surplus is the money we save. And but unfortunately, again, in reality, when we go to the market, we just talk to the manager for the supermarket. What's the demand curve? Can you give me some information? And what information we get is the price. We can collect out of a price level. At the same time, we ask them how many chicken eggs you are selling for each week. We can get also a lot of data on the quantity. And based on that, we can construct a curve. We can draw a curve. We can do that. But what's the curve? The curve is usually not the Higgs curve. It's instead what we call marshalling demand. So this is something you're familiar. When the price drop from high level to low level for goods X, but goods Y, the price doesn't change. And then the consumer's consumption plan will change from this level to next level. This is another let me redraw it to a little bit better, I hope. Okay. So when the price change, but the income doesn't change, what's the consequence for the consumer? If the consumer spend all the money on goods Y, nothing change because the price goods Y doesn't change. If she can spend all the money on X, she can buy this much and the old price, and buy this much and the new price. So therefore, after the price change, but the income doesn't, the old optimal solution is here. The new solution will be here. So from this point to this point, that's the change in consumption for goods X. This is total effect. And so far we consider this part. This part, just recall what you learned in intermediate macroeconomics. This is what we call, this is the substitution effect, right? And so therefore, Hickson demand only consider the substitution effect. But at the same time, this one, the change, sorry, I should draw. No, let me redraw the curve. This one should be parallel with this one. Oh, yes, let me redraw it. Okay, this one is parallel to this one. So sorry. So this curve, this is the new price. This is the new price. But this is the new price for the old utility. This is the new price for the old income. Okay. So the change from X1 to X2 is due to substitution effect. The change for this part is due to income effect. So, and now if we consider this one, sorry, this should be, okay. And so this is the change from this level to this level, let's call this X3, is due to the total effect, not only substitution, but also income effect. You know, this is what you learn and what you have spent much time, I believe, your lecturer, your professor who taught this part, intermediate macro part 1, must have spent lot of time for training, for exercise, and to break down the total effect into substitution and income effect. And if we consider both effects, we can consider the change in consumption. And when the price change, this is X1, this is X2. And if we consider only the substitution effect, we get the demand, there's Hickson demand. If we consider both, we get the Marshalling demand. And clearly, here, if we are considering normal goods means if you consider change from this level, this point to this point, the price the same, but the consumer income increase. And then if X is normal goods, by definition, the more money you have, the more you consume. Then the consumer will buy more from X2 to X3. So therefore, for any normal goods, the change in substitution effect and the change due to the income effect is in the same direction. If it's not a normal goods, you know, for example, constant node 方便面、速食面, okay, when you become richer, you will eat less, you will consume less. That's not a normal good, that's inferior goods. But here, let's consider normal goods, because In most situations, we are dealing with normal goods. The more money, the more we buy. Very simple. And then now come back to our topic. For normal goods, this is marginal demand curve. Okay, but this one is fixed demand curve. So clearly, the two curves are not identical. Some gap between them because they are dealing with, different things. Margin demand take care for not only substitution but also income effect. And now coming back to our our task, which we just imagine we promise to undertake for the macro government. And let me tell you how much benefit in dollars the mechanism the macro people can get from the price change. And we go to the market, we talk to the managers, we collect a lot of data, and we can get a curve. But the point is, the curve we can really get from reality is this one. You can't ask the consumer, the people, okay, don't change life quality, even if, you have more money, the price is lower. That's very stupid. If the people are rich, naturally they increase their life quality, they improve life quality. So therefore, what we can get is this curve. But so far, in theory, we have proof this curve is very nice, it's very beautiful. Because based on this price, we know what we are doing. This number is the money we receive. Intuitively, it's a very attractive idea, okay? And now we have a trouble. This is a beautiful theory. This is ugly reality. The gap between theory and reality is this part, okay? And so now let's introduce a powerful result. This result will tell us, don't worry, it's true. Reality is more ugly, it's messy, it's not very clean. But don't worry, the gap between reality and the theory is rather small. It's quite small actually, and we can quite generally prove this number is small, but that will be very mathematically difficult. It requires a lot of mathematics. We will not do that. Instead, let's look at one example. This example itself is quite general because this example covers many situations and which is relevant in economic analysis. So therefore, this example is enough to convince us that, don't worry, this number is rather small. And this curve is, just nice. This curve is somehow diverging from this curve, but as far as consumer surplus, the change in consumer surplus is concerned, and it doesn't matter much. It really doesn't matter very much which curve we are using. That's what we are doing next. Let's look at one example. I hope you now understand the motivation why we consider the two in consumer surplus based on two different demand curve. So let me continue this thing. And now let's look at one example. This example again is our old friend, which we have made a long ago when we study intermediate macroeconomics. What's that? This is Kerber-Douglas. Kerber-Douglas utility function, alpha plus beta equal 1, both positive. And this is the utility function. And now we have some budget constraint. The budget constraint is I, that's the income, and the price Px and Py. And but the point is, suppose Py doesn't change, but Px drop. Let's consider a drop. If we increase, all our analysis will be roughly the same. We just be careful to look at the decrease in consumer surplus if the price increase. But now, let's consider if a price decrease, drop from high level P1 to low level P2. And that's what we just look at from the curve, price drop. And then what we needed to show, we needed to analyze is this. For this Kerber-Douglas utility function, the price drop, let's look at what we can see if we are using the two different demand curve. One is base idea for marshalling demand, another Hickson demand. So you know, in terms of calculation or in terms of analysis, it's much easier to consider marshalling demand because for marshalling demand, we only focus on the change in we only focus on the total effect, and we don't need to break down the total effect into two parts, and that will make our job, our analysis much simpler and easier. You know, in Chinese, we have a very childish and joking, but a very smart way to see this. 一国主，不要分开煮，一国煮掉 is much easier. It's a lazy guy's way for doing business, but it's a simplified job. So let's look at what we can get. And based on the first order condition, for any level or for whatever price or whatever income, for the consumer to maximize utility, this must be true. This is the margin rate substitution. So you can easily calculate by using this utility function, the margin utility for X over margin utility for Y equals this part. This part of the consumer's preference must be equal to relative price, Px over to Py. And now let's reorganize this one. We put X times Px. Basically, you just multiply by X on both sides. You get X times Px. At the same time, on the denominator part, 分母上, okay, you are doing the same thing. And multiply Y on both sides, that's Py. That's Y over Py. Alpha over beta, still over there. And now, mathematically, it's easy to move forward, but economically, it's a smart way is to look at the problem from an economic perspective. What's the meaning for this one? Sorry, X, let me make a little bit larger. Okay, so this one, the numerator is expenditure on X. The denominator, sorry, is expenditure on goods Y. So the ratio between them is alpha over beta. So for example, if alpha equals 40%, beta equals 60%, then the consumer will always spend 40% of the income on X, 60% of the income on Y. So therefore, Kerber-Douglas utility function has such a wonderful, very nice property. That is, regardless, no matter what the prices are, even if very expensive or very cheaper, then one thing never change. That is, expenditure on X and the expenditure on Y is always proportional to alpha over beta. So that is, the consumer will always spend alpha times total expenditure, 40% of the income on goods X. So therefore, what she consume at optimum is always equal to this number divided by the price. Okay, this is for X. Similarly for Y, 60% of the total budget on Y. So therefore, this is the money divided by the price. This is consumption for Y. And for this step, at the moment, you just ignore it. And I did that for some other purpose, which will be clear very shortly. So this is the so-called marshalling demand. Let's look at the Hickson demand. Do you have any question? If you do, and drop me some message or just speak up, or just drop me a message from the chat, the chat section. That will be much more effective. Okay, now let's consider Hickson demand. And at any price level, and suppose the Hickson consumption plan is X and Y, then what can we see about it? Then the following two conditions must be true. One, utility doesn't change. That is, if you plug X and Y into the Kirby-Douglas utility function, you get some utility. This utility must be the same as original utility level. What's the original? Remember, at the very beginning, the price of goods X is P1. So therefore, this is consumption of X at the very beginning. This is consumption for Y. And this one, we simplify this term. We get alpha to the power of alpha, beta to the power of beta. I to the power of alpha times I to the power of beta. Because alpha plus beta equal 1, we got the income I. And the P1 to the power of alpha, Py to the power of beta. So this is the utility. That is, it doesn't matter at whatever price level, the consumer's utility will be always the same, this one. This is the one condition. Another condition, as mentioned earlier, when the price drop at any level, for example, at this level, at this point, what happened? At this point, the price, if we draw the budget, this straight line, this stands for the slope of this stands for equals Px over Py. This one must be the same as the marginal rate of substitution at this point. So this is another condition for the Hickson demand. Let me. Okay, let's come back to continue our calculation. So this is the second condition. The second condition is marginal rate of substitution always equal to relative price. And then we reorganize this term in a way we feel more comfortable. X over Y, X basically multiply x on both sides on the, the numerator part, 分子上, okay, on the denominator part also, then you get x over y equal to alpha times py divided by beta times px. Why do we do that? What's the point for doing so? The point is we want to find out for any level of price, the value for x. This is the Higgs demand at px. This is what we are looking for. But here the point is equation 1 has two variables x, y. Equation 2 has two variables x and y. We want to get rid of y. Okay. How to get rid of y? When you put it into this way, then you consider to the power of beta on both sides of this equation, you get this one. And now it's nice. Here we have this term. Here we have y to the power of beta. Sorry, another term. So therefore, if we take the multiplication, let left side times the left side, right side multiplied by the right side, then beta naturally are canceling with each other. Sorry, y to the power beta, this term. At the same time, x to the power of alpha times x to the power of beta, that will be equal to x. Okay, but this x is what we call Higgs demand. Sorry, this px should be. There's a small mistake. I should emphasize. This x should be px. Okay, at px, the Higgs demand equal to this one. And now look at the right side. This term times this term. What can we see? Firstly, the beta disappear, right? This is very nice. And let's look at alpha. Alpha to the power of alpha, alpha to the power of beta. So therefore, alpha to the power of alpha plus beta. That is alpha. Oh, that's very nice. Alpha also finished. And then what's the py? Py to the power of beta. That's nice. Py to the power of beta. Okay, py disappear. What's left? I, that's okay. P1 to the power of alpha. Px to the power of beta. So therefore, the Higgs demand function is not that ugly. It's also okay, equal to the current level of price of goods y and original level of price P1. Why P1 matter? Because when we consider Higgs demand, we fix the utility. What level of utility we fix at? At the old price P1 level. So that's why in Higgs demand, we must have P1. Because Higgs demand also capture some information about the original state. In the original situation, the price is P1. So therefore, that price must be part of the so-called utility level. And now I can tell you why okay. And now I can tell you why I put the marginal demand in such a childish way. Px, we put Px as Px to the power of alpha times Px to the power of beta. Clearly, this is still Px. In doing so, this is Higgs marginal demand. If you compare with Higgs Hickson demand, you will find this part is exactly the same as this part. Okay, so therefore, to know which number is bigger, we need to know to compare this part and this part. That's the only difference. But Px is some price below P1 and above P2. So therefore, this number is always larger than this number, except at the original level P1, they're the same. Otherwise, this number always be larger than this number. And this is precisely what we have discussed, when we consider another curve. Let me we just discussed, this is the Hicks marshalling demand. Sorry, this. Okay, so this number is always larger than this number. So that is the marshalling demand curve is always on the right of Hickson demand. And so therefore, what we just discussed, just confirm this economic intuition. Okay, let me come back. Okay, so that's why we put the margin demand in this. So now we have got the two curves. Now let's come to our main task, our main job. We want to compare how big the change in consumer surplus will be if we are using the two different demand curves. Oh, it's really annoying to change again and again. Okay, now, firstly, let's look at the marshalling. Okay, we don't need to change any more. So this is the marshalling demand. Marshalling demand equals this one, alpha I over Px. So therefore, do you remember this one equal to alpha I over P. P could be any price between P1 and P2. So therefore, this one, the original function for this one equal to alpha I times log C, right? So therefore, from P2, so it's a little bit messy, to P1, we get this one. So this is the change in consumer surplus based on marshalling demand, okay? And for the moment, let's ignore this part. We do this only for comparison between the two numbers. Now let's turn to Hickson demand. Sorry, this is Hickson demand. So for Hickson demand equals this one, okay? And now this one, alpha I and P1 to the power of alpha, this part is only constant number. What matters for the integral calculus is only this part. This is Px to the power of minus beta. Okay, so therefore, the original function equals 1 minus beta times P, just forget x to simplify, no x, 1 minus beta. Okay, so this is what we get, 1 minus beta. 1 minus beta, and of course, you need to consider the so-called definite integral calculus from some number to another number. C1. The end point is a bigger number, the starting point is a small number. Okay, we get this one. And this part is this part. You just copy it and paste, and nothing changed. So therefore, this is the change in consumer surplus based on Higginson demand. This is what we call CV, the composition variation. This is the change in consumer surplus. And now we need to compare the two numbers. Let me make a little bit. Okay, this is the change in consumer surplus. This is the CV. We want to compare the two numbers. We want to show, and intuitively, this number should be bigger than this number because, the curve, this curve on the right of this curve. So therefore, we have a sort of gap between the two curves. So therefore, between the two numbers. But now we will show that the gap is pretty small, actually. And after we do the stupid job, the stupid job is the mathematician's job. It's mathematics. We come back to we come home. We go to the smarter job. The smarter job is the economist's job, with the economic intuition. And now let's firstly deal with the dirty part, the dirty job. The dirty job is mathematics. We want to compare this one, the whole thing, with this one. Okay. And now let's see what's the common. Common part is this number, alpha times I. Alpha times I, the same. So therefore, we don't need to consider this part much. We just copy and paste. And the difference is log P1 over P2 and this one. Clearly, this one is much more, let's see, ugly, much more complicated. And we want to show this number is actually pretty close to this number. And now, how to do that? And mathematically, this is the log. That's kind of a very strange function. This is, a kind of power function or exponential function. Let's try to draw them, together. You guys now, it's so far away from each other. And I can't see clearly how close you are. Let me change your face. How to do that? Let's try to figure out. When we consider change of a price, come back to economics. What does that mean? we don't care about the number. We usually care about the change in percentage. For example, this is the price for April. From $5 to $4. $1 is the drop in price. But if you measure the price not in Patakas, but in Hong Kong dollars, this number will become 5 point something. This number will be 4 point something. And at the same time, the ratio of two prices is still the same. So what matters for us, for the consumers? So you can imagine we have consumers who live in Macau, but he's Hong Kongese, and he or she has a very bad habit. She tried to change all the prices in terms of Hong Kong dollars. Okay, many people still do that, and that will not change their consumption plan. That will not change their utility, but it does do it. What can we learn from that? The important message is what matters is not P1 or P2, it's instead P1 over P2. What does that mean? That means when the price change, what the consumer really care about is the percentage change. Let me emphasize percentage change 降价的百分比. That is what matters. So therefore, for that reason, let's reformulate this one P1 over P2 in such a way. This is all the price. This is still all the price minus the change in price. And now we can get something nice. Divided by P1 on both numerator and the denominator. Then this part become 1. This part become 1. This part become delta P. Delta P is the change in price over P1. Okay, but here the numerator is 1, the denominator is 1 minus this one. Then we should focus on this part, and clearly we give a minus alpha I and times this number. So now we have already get a very nice result. The change in consumer surplus is a function of change in price, percentage change. Okay, because only percentage change in price which matter, and the absolute value of a percentage doesn't matter. So therefore, we get a pretty nice result. And now let's make something roughly equal to each other. Because we want to figure out how the value for this function log something will be when the price change a little bit, not very big. If the price change is not very big, this number is pretty small. Okay, and then we claim this one log. Here you should refresh your knowledge in calculus a little bit. For very small value for x, the x could be positive number, could be negative number, that doesn't matter. For any small x, this must be true. Okay, you can confirm this by what you have learned from, I don't know, from whom, from the mathematics, that's the very. The idea is when x is small, and this one, the value for this function will be equal to log 1 plus x times the the first order derivative at when x equals 0. That will be roughly equal to x. Okay, so you should confirm this one. If you can't do that, please go back to your notebook in mathematics, and this is always true. So therefore, we can get this result here minus here minus. Then we can put them together. We get this one. Okay, now before we move forward, any of you had question about this step? I guess the only possible point you may have difficulty understanding is this point. It's from this, basically this one. Okay, you can discuss with the classmates or go back to your notebook if you have trouble, or you can ask question now. You okay? Okay, good. Let's move forward. And let me Okay, now let's turn to the Hickson demand. For the Hickson demand, we are doing the same thing. And now again, we have a very little bit complicated function, but fortunately, and if you look at it carefully, it's even simpler than the first one. How come? Because 1 minus beta is equal to alpha. So therefore, this one alpha, so this is alpha. This is also alpha. They cancel with each other. And so we will eventually bring another alpha back. But for the moment, the two terms are canceling with each other. I left. But what's this one? This one, if you consider this one together with this one, -1 minus beta is alpha. 1 minus beta is alpha. So therefore, we get 1 minus P2 over P1 to the power alpha. So this one seems to be quite simple, right? And now, again, let's consider this term. This is the new price. This is the old price. And this term equal to P1 minus the change in price divided by P1. Okay, so a delta P for cards equal to P1 minus P2. So you just reformulate this term in this form. So what's this? This is 1. Sorry, this is 1 minus this one. And so now again, we eventually train the whole thing into function of percentage change in price. This is the percentage change in price. How many percent of the price drop? Okay, this is the percentage change in the price. So this is the function. Again, we are making use of some mathematics. We turn this one as another as a linear function of a data percentage change in price, delta P over P1. How to do that? Again, here let me, just in case some of you forget about the simple, the calculus mathematics. This one, when x is small, when x equals 0, it's clearly equal to 1. And when x become a little bit divergent from 0, when x could be small, could be positive, could be negative, that doesn't matter. Doesn't matter, equal to this number. For small x. Oh, it's very hard to. For small value for x, it's roughly true. The idea is you need to consider the first order derivative of this one is to the alpha times 1 plus x to the power of alpha minus 1. When x equals 0, then that equal to alpha here. So when x change by this one, the change in the function, in the value function is this one. This is first order derivative. This is the change in independent variable. Okay, that's it. So therefore we get this result. But again, oh, sorry, this is, I made a mistake. This is should be, I will change it in the file. So I will change it in the file. This is the 1 minus. So because, so let me see here, this one equal to 1 times alpha and the small change in x. Okay, so this is this term. And then 1 minus this one. Sorry, I will correct all the small mistake and then resend the file, put it into the UM model. And then this one, 1 minus 1 at 0, minus and minus become alpha times this number. And also I, we get this one. Sorry, this is something wrong. I should change it in the file. And then this, I mean, this step, this one should be equal to 1 minus the whole thing, and not this one. So I will change it in the file and put it again into the model. I just prepared this file in hurry and made some mistake. And then, anyway, we eventually get this result. And now, if you compare the two results, you may find the same. So now, we just finished the dirty job. the stupid job in mathematics. Now let's try to understand what we are doing. What we are doing basically is to argue for almost obvious in economic terms. If you ask economists, just guess, whatever the formula is, based on your economic thinking, economic intuition, tell me, if the government of Macau decide to drop the price, what's the change in consumer surplus? Roughly, if the price change is not very big. And for a good economist, for a senior scholar, probably he or she can be immediately tell you this is the answer. If after a lot of calculation, your result is different from this one, likely you are wrong. The economist is correct, is right. Why? Economic intuition must be leading to this result. The idea is, think about this one. Focus on April. We are now talking about the price drop for April. If April becomes cheaper, what's the meaning? The meaning is I spent as a consumer this much money on April, right? No matter what the price of April is, I don't care. Whatever price, given my Cobb-Douglas utility function, I always spend this much money on April. Okay, and now the April becomes cheaper. How much? This is the change in price. Okay, and the change in price, you can understand the meaning of the product between the money. This is how much money. For example, I spend $40, I have $100, and alpha equals 40%. That means I always spend $40 on April. Then, if I don't change, and the old price P1 equals $5, I buy 8 Aprils. Okay, and now the price drop by $1. Okay, then I can save. I can benefit from $8. Okay, so in other words, that's one way to understand. Another way is, now imagine, no matter what the price is, I always spend $40 on Aprils. Okay, and now the price drop. You ask me, what's the meaning for this one from me? How much benefit I can get from this one? I will basically I can see if I can benefit from this number. So the idea is, this is the total income. This is the percentage change in price. Okay, and if I don't change anything at all, what's the meaning? The meaning is I can reduce my expenditure on April. How much money I can reduce? This must be this number. This is basically my benefit from the macro government policy. So this is the sort of economic intuition. The idea is the price doesn't change much. This number is quite small. And clearly, when the price change, you change everything, right? You change not only your consumption, change your expenditure, also your consumption, change everything. But the point is, you can focus on this first order effect and ignore the secondary order effect. And because the change is small, this number is small. This is the key idea for the so-called economic intuition. So let me put this idea, we don't have time once more for question. So let me explain this point in Chinese. Hopefully you can understand. If you can't, that doesn't matter. 这就是最后我花1-2分钟把这个所谓聪明人的想法，以尽可能不那么笨蛋的方式给大家用中文解释一下。就是为什么说经济学家一个好的经济学家可以凭着直觉，不这些计算这都是一些垃圾东西，不理它就对了，直截了当的说出答案。这个答案是什么呢？他会猜，是我花在苹果上的钱乘以降价的百分比，这就是我从澳门政府那里拿到的好处。这个怎么理解？2个角度去理解，其实2个角度仔细想想是一个角度。第一个角度是说，假如说我不改变消费习惯，我就算算我省了多少钱。原来是5块钱一个，我吃8个苹果。现在呢，你给我降了点价，很好呀，那我的改变生活习惯不变，这我就可以8乘以你的降价。你要是降1块钱，我就赚8块钱；你说降这个1毛钱，我就赚8毛钱。这是很直观的。这个直觉本质上是走的 Hickson 的想法。OK， 就是说我不改变生活质量，就这么着混了，反正我把这个钱给你花下去。我不改变生活质量，怎么不改变呢？我连消费习惯都不变，那生活质量就不变。因为那个所谓的生活质量来自消费量，我 X 和 Y 的消费都不变，我就是个老顽固，就死活不改，我就看看省多少钱。那你大概省的就是这个数除以老价格，乘以省下来的1个苹果能省这么多钱，那8个苹果就省这么多。这是一个直觉。第二个想法就是第二个直觉是本质上来自 Marshalling curve， 还是这个数直截了当的乘以对它 P 除以 P。他的意思是说，好了，反正我是 cover Douglas， 别管价格怎么变，我永远是40块钱花在苹果上，我就这么花了。现在呢，这个东西发生降价了，那我的这个钱的变动量相当于价格的变动量。这个稍微有点抽象，我们下节课再稍微花点时间解释一下。就是本质上，反正我就苹果就花这么多钱，这40块这是固定了的，然后这个东西乘以一个数，这个数呢就是我节约的我得到的好处。We are running for time. We can't continue. 所以，但是这个想法呢，大家仔细揣摩一下，这个是我的这个价格下降的百分比，这个就相当于说我这个钱的这个物有所值，购买量会稍微增加一点点。这个数是多少？我们下节课再解释好了。所以这2种直觉呢，如果经济学家训练有素，就会脱口而出，一定等于这个数，否则是一定数学家搞错了。经济学家不会错，但不是说经济学家那么聪明，而是说，因为你讲的是个经济学的故事，必须符合经济学的逻辑，而经济学的逻辑是直截了当的，没那么啰嗦，一定是等于这个数。所以你算来算去就是 confirm what you know already in economics, but you need to confirm yourself by mathematics. So sometimes I did make a lot of mistakes, but this does not really matter. You know the answer. You know how to figure out the details step by step, but you know already this must be the final result. So this is kind of economic intuition. So after this class, I will shortly put the first assignment into the UM model. So please check your model. And also ask other students, other classmates who may not come to class regularly, remind them to check. I will probably send some email to remind everybody about the assignment. Sorry, I'm sorry again for not leaving time for question today. Because I struggled to finish all the points because they are useful for you to do the first assignment. So that's all for today. Take care, everybody. It's time to say bye. Bye-bye.